Code to Enhance Learning presents the CEL video series for creating projects that integrate computing with the world around us using Arduino UNO. Through this video series, we aim to introduce you to the world of physical computing and the Internet of Things.
Hello everyone, I am Ayush Sankaran, an enthusiastic coder and a regular CEL hackathon participant. I will be your host for today.
Welcome to the third episode of the series, How Far Is It? In this episode, we are going to find the distance from an object using the ultrasonic sensor. Ultrasonic sensor or ultrasound sensor is one of the most used sensors in various projects. It is generally used to find the range or distance of objects. The sensor produces an ultrasound which is transmitted through the transmitter. If an object is present in front of it, this sound is reflected back and is received by the receiver. The distance is calculated by calculating the time traveled by the sound and velocity of sound. An ultrasonic sensor has a lot of uses in real life. An automated parking assistance system, a water level detector system, a weather sensing system, etc. are a few of them. Once you understand how the system works, you can find many other areas where you will see an ultrasound sensor at work. Today, we will calculate the distance from an object using an ultrasonic sensor in our project. Let us look at the components we will need for our project. We need the Arduino microprocessor, the ultrasonic sensor which has 4 pins, the jumper wires. We will be using the wires which do not have a pin at one end. We also have the cable to connect to the computer. The ultrasonic sensor module has 4 wires: power VCC, trigger trig to transmit signal, echo to receive signal, and ground GND. We connect the ultrasonic sensor's VCC pin to the 5V pin in the Arduino board. We connect the trig pin to digital pin 10, the echo pin to digital pin 11, and the GND pin to the ground pin of Arduino. Now we will make the connections. First, connect the jumper wire to VCC. Similarly, I connect all 4 wires, which looks like this. We then connect the wires one by one to the Arduino board. Finally, we will connect the Arduino to our computer using the connector cable. You will see that the Arduino lights up when connected. Now, we will move to coding our project. We have opened a new project on mBlocks and signed into our account. If you do not know how to do this yet, please view the first video in this series, which has instructions to install mLink driver and create your credentials. Once inside the project, you can rename the project to How Far Is It? Now, we will connect the Arduino to our project. From the Devices tab, I click on the Add button and select Arduino UNO from the list. Then I click the Connect button. Now I see that our device is connected to our project. We also need an extension to our project, so I click the Extension button. Here, under Device Extensions, I will use the search bar on top to search Upload. Then I will choose the Upload Broadcast Mode extension by the developer mBlocks to add to my project. From Events, I bring the block when Arduino starts up. Keep watching the corresponding codes coming up in C language so you can understand how to code in C language as well. First, we need to transmit a signal from our sensor. For this, we will set the digital pin 10 output to high. As you know, digital pin 10 is connected to trig, which is our transmitter. Then, we wait for 0.25 seconds. Next, we duplicate these two blocks. We set the pin 10 output to low. Next, we bring the upload message mode block, which will upload the signal received from the digital pin 10 to the echo pin 11. We will wrap all these codes in a forever block so that we can track the distance continuously. Next, we will code the panda sprite to tell us the distance from the object. So, I will go into the sprite lab and write my codes in the panda sprite. I need to add an extension to the panda as well. So, I click on Extensions and under Sprite Extensions, search for Upload. Now, I add the Upload Broadcast Mode extension by the developer mBlocks to my panda sprite. The panda will tell the distance as soon as it receives the uploaded message from the sensor. So, from the Upload Mode Broadcast tab, I bring the event when receiving upload mode message. Now I need a variable to store the distance value. So in the variables tab, I will create a new variable and name it distance. Next, I will set distance to the upload mode message value. Then I will make the panda to tell the distance. Now that we have written the code, let us upload it to the Arduino processor by going into the Devices tab and clicking the Upload button. As you can see, the code has been uploaded. This brings us to an end of our coding project. Let us test our project. As you can see, I have kept my hand on the sensor, hence distance shows 0. As I move the hand back, the distance will increase. If I bring the hand closer, the distance will become lesser. Let's try again. We have a fully functional project now. Can you think of ways to bring more precision to our project? One way is to reduce the wait time to capture the distance. We currently have 0.25 seconds. Can you try with 0.01 seconds? Will it make it more precise? Think about it and also try experimenting with different wait times and different objects to see how your project reacts. In the next episode, we will be creating another project to measure temperature and humidity. Till then, stay tuned. This is Ayush signing off. Bye.